In this lesson, we're going to see how the derivative can be helpful to find intervals of increasing and decreasing on a function. All right, let's take a look at this function here. And we've got this graph on the right over here. Got this cubic function. So let's start out by finding its critical points. So we find the critical points by finding the derivative. So the derivative, f prime of x here, is going to be negative 2x squared plus x to the third plus x to the fourth. We're using our power rule, dropping that down, multiplying, and subtracting 1. Now we can factor this. So we factor this here. We get, let's see, I think we can pull out a x squared, right? So let's pull out an x squared, and that leaves us with negative 2 plus x squared. And that's a quadratic in there that can be factored. Two numbers that add to 1 and multiply to negative 2. It's kind of backwards here, right? Add to 1, multiply to negative 2. Well, let's see. That's going to be x plus 2. X minus 1 sounds good. And that gives us our critical numbers are what makes this 0. So we want to set this equal to 0. And that gives us these x values. X equals, well, 0 will make this 0. What makes this part 0? Negative 2. What makes this 0? 1. So we have 0, negative 2, and 1. You can see that's where we have our critical values here, our minimums and our maximums at negative 2 and at 1. And at 0, it's not actually a min or max. It's what we call an inflection point. So these are our critical numbers. So now let's find out what's happening in between them here. All right. So we want to find out what's happening from 0 to actually negative infinity to negative 2. So that's this part over here. And what's happening to that function? Is it increasing or decreasing? Well, remember, we're always talking about this function going left to right. So we're climbing up, that is increasing. Okay. And then from negative 2 to 0, we're dropping down, that's decreasing. And then from 0 to 1, that's decreasing. And last but not least, from 1 to infinity, well, the function is going to be increasing forever there. Okay. Well, now, how does that relate to the derivative? Well, if we plug in values for the derivative, like negative 3 or something, if you plug in negative 3 here, you'll get a positive number. Plug in negative 3, you'll get a negative number. And another negative number. Positive times negative times negative. So that would be positive times negative times negative. Well, that's going to be a positive number. And you can also tell the derivative is the slope here. Derivative slope is going up. That's positive. So you pick any point over here, and the slope will be positive. Okay? So we can find it from the equation or from the graph. How about between 2 and 0? So negative 2 and 0, that is. So in this area here, we are decreasing. It's dropping. So this slope will be negative. Pick any point there. And the slope, which is the derivative, is negative. And then from 0 to 1, that slope will be negative also there. And then after 1, the slope turns around and it's going up. So this is a positive slope here. Pick any point over here. And we have positive slope. So what can we conclude? Well, pretty easy to see that if it's increasing, the derivative, which is the slope, is positive. If the function is decreasing, like in these intervals, well, it's going down to the right, and that means the slope is negative. The slope, which is the derivative, is negative. And then at certain points where the f of x is constant, that means for just this moment, okay, where it turns around, or this moment right here at this 0 where it almost turns around, but it kind of flattens out for just a moment, the derivative is 0. So this gives us our test for increasing and decreasing. If the derivative is greater than 0 or positive, then that means the function is increasing. If the derivative is less than 0 on the interval, then the function is decreasing. If the derivative is 0, the function is constant or flat. All right, so let's test this out. Let's give it a try. So let's find the intervals of increasing and decreasing here for this function. F of x equals x cubed minus 3x squared minus 24x plus 1. So we need to start by finding our critical values. So that means we need to find our derivative. So the derivative here is going to be 3x squared minus 6x minus 24. And I think we can factor that. We can factor out a 3, leaving minus 2x minus 8. And we can factor that into two numbers that add the negative 2 and multiply to 8. I think that's going to be x minus 4 and x plus 2. So our critical values will be what makes that 0. I'm going to set that equal to 0. And the critical values happen at x equals 4 and x equal negative 2. Now that we have our critical values here, we can find our number line. Okay, and we can put our critical values on here. Now this is a number line for f prime. Number line is going to be really useful to us. So we're going to use this in a lot of different ways. So it gives us a good map of what's going on. So at negative 2 and at 4, we got our special points. You don't need anything other than that. And now we're going to test some points. Okay, we're going to pick a number in each interval, and we're going to plug it in, and we're going to see if the derivative is positive, negative, or 0. Well, we know it won't be 0. We already found the zeros. So we're going for positive or negative. So let's plug in something from this side like negative 3. Now if you plug in negative 3 here, all right, let's make a little table. This is helpful here. Okay, so we're going to test some points. X and f prime of x. Okay, and we're just looking for the sign is all we're looking for here. So if we plug in negative 3, we're going to get, plug in negative 3, you get a negative number and a negative number. So that means this is negative times a negative, which is positive. Okay, so this is going to be positive. Plug in a number between negative 2 and 4, maybe like 0. 0 is a nice number. Plug in 0, we get a negative number. Then we get negative here. Plug in 0, sorry, we get positive number. Positive 2, huh? So negative times a positive is a negative. So this is going to be a negative. And we plug in something to the right of 4, maybe like 5. So if we're going to test out 5, plug that in, we'll get 1, which is positive. And we're going to get a plug in 5 here, we get 7, which is positive. And that's positive. Again, we don't really care what the exact numbers are. We just care that they're negative or positive. So we don't need to do full calculations there. And you notice I plugged this into the factored form. That's a little easier to work with. Okay. So what's going on? This is going up. This is going down in this interval and up. Okay. So we can state our intervals of increasing and decreasing. Our increasing intervals are from negative infinity to negative 2 and from 4 to infinity. For decreasing, we know that it is from negative 2 to 4. So we don't actually have to graph this function now to know the intervals of increasing and decreasing. All right? Well, let's try another one here. Let's try one with a 2/3 power, which is a radical, right? So this is the cube root. So it's x squared minus 4 squared, cube rooted, but we'll write it as 2/3 power. So the first thing we got to do is we're going to find the critical values. And so we'll go f prime of x. Now we need our chain rule. Derivative of the inside is 2x. Derivative of the outside, well, we're going to drop that 2/3 down. And we'll have x squared minus 4. And we'll subtract 1. 2/3 minus 1 is negative 1/3. Now it's going to help us to rewrite this. Okay. Simplifying is going to be useful because we've got to actually use this function now. So we've got this. So it's going to be a fraction. We've got on bottom, we've got this 3. On top, we're going to have 2x times 2, which is 4x. And then, which I think I can center that. That's all that's going to be on top. And on bottom is x squared minus 4 to the 1/3. I'm going to make it positive because it's negative on top, positive on bottom. All right, cool. So let's find our critical values. These critical values happen when the whole function is 0 or undefined. Well, what makes this fraction 0? Remember, a fraction is 0 when the top is 0. So what makes 4x equal to 0? Well, that is when x is equal to 0. Divide by 4, you got your solution there, right? What will make this fraction undefined? Well, that's undefined when the bottom is 0. And what makes the bottom 0? What makes 3 times x squared minus 4 to the 1/3 equals 0? Well, if we divide by 3, we get 0 on both sides and then cube root. So x squared minus 4 has to be 0. Add 4 to both sides, square root. X equals plus or minus 2. Okay, so this is undefined. In other words, it's not differentiable when x is plus or minus 2. So our critical values are 0 and plus or minus 2. So that gives us our numbers that we need for our number line here, our derivative number line. So that's, and we got, let's see here, -2, 0, and positive 2. And now we need to test some points. Let's test some points on each side here, right? So we're going to test it in f prime. So let's test the number to the left, like -3. Well, if you plug in -3, the top is going to be negative. Okay, the bottom, well, you plug in -3, that's going to be 9. 9 minus 4 is positive. Cube root of that times 3, it's all positive. So this is negative divided by positive, which is negative. So this is going to be negative. Plug in a number between -2 and 0. How about -1? So plug in -1, and we have negative on top. And -1 down here, we'll have -1 squared is +1. Minus 4 is -3. So that's negative, cube rooted, it's going to be negative. So negative divided by negative is positive. And then we have between 0 and 2. So pick a number. Probably 1 is a good number to pick. So pick 1. What makes, well, plug in 1 here, sorry. Plug in 1, that's positive on top. And on bottom, we have 1 squared, which is 1 minus 4, which is negative. So this is positive and negative. So that is going to be a negative number. Positive divided by negative is negative. And last but not least, plug in a number from over here. How about 3? Plug in 3, positive 3. And we're going to get a positive number on top. And plug in 3 on the bottom. We're going to get 9 minus 4, which is positive, and the whole bottom stays positive. Positive divided by positive is positive. So we're just testing positives and negatives there, okay, in the derivative. And so it's easiest to use this little fraction, right? Notice these things are the same, but probably easiest to plug that into the fraction so you can get that right. Okay, so what's going on? So we're going down, decreasing, increasing, decreasing, increasing. Okay, so we got increasing, That's going to be from negative infinity. Nope, sorry. Let's try that again. From negative 2 to 0. And from 2 to infinity. So increasing on these two intervals, this one here and this one here. Decreasing is going to go from negative infinity to negative 2 and from 0 to 2. And that covers the whole gamut there. Okay? All right. Now again, we don't really know what the function is, but we know where it's going to be going up and down, so it gives us a good idea. We could go talk about graphs, which we will soon in a future lesson, but right now just figuring out what's going on. All right, one more here. We have a quotient going on here. So let's find our critical values by finding the derivative here. And so the derivative is going to, again, take the quotient rule here. So we have the derivative of the top is 4x cubed times the bottom, which is x squared, minus the top, x squared plus 1. Nope, sorry, can't read. How about x to the 4th plus 1 times the derivative of the bottom, which is 2x, all over the bottom squared. All right. Now, let's clean this up a little bit here. We have 4x to the 5th minus, and you know what? Watch this. Let's not multiply that out. You can, but I'm going to leave it. You'll see why I'm going to factor out that 2x. Okay, so we want to factor on top here would be the best way to go. And what can we factor out of both of these here? So we got two terms right now. We have 4x to the 5th, and we have 2x times the parentheses there. What do they have in common? They have in common 2x. So we factor out 2x. That leaves us with 2x to the 4th minus the parentheses x to the 4th plus 1. So do some careful algebra here. If you go too fast, you're likely going to make mistakes that you might regret. And yeah, so just keep things in order there. And so what's going on? We can cancel one of these x's with one of these x's. That'll make it x cubed down here. And what else? We can clean up the inside of the parentheses. Let's go ahead and do that. So this is 2 times, so we have 2x to the 4th minus x to the 4th. That's going to leave us with x to the 4th. Okay, so this is going to be x to the 4th. And then we have minus 1. Watch out for that. Okay, going to be really easy to forget that. Okay. All right, so we've cleaned it up. We've found our derivative there. There's our derivative. We want to set that equal to 0. Okay. And we'll find our critical values. So our critical values. What makes this whole thing 0? What makes the top 0? Well, what's going to make the top 0 is going to be 1 and negative 1, right? If you plug in 1, you get 1 minus 1. If you plug in negative 1, you'll get the same thing. So critical values, x equals plus minus 1. And what makes the bottom 0? Because that's going to be an undefined point. That's 0. So there's our critical values. So we're ready to make our number line here, our f prime number line. And that is going to happen. That's negative 1, 0, and 1. We mark our critical values, and we're going to test it in between here. All right? So let's do our test here. Put a little table down here. Okay? And you can probably get away with this table, without this table, I should say, but I'll just write it out so we can see what's going on. All right? So if we plug in something to the left of -1, that's something like -2. All right, so if you plug in -2, you're going to get on top -2 to the fourth minus 1. That's going to be 4 minus 1. That's positive. Okay, so we get positive on top. Plug in -2 on bottom, we'll get negative because -2 cubed is negative. And so that's a negative number. Plug in a number between -2 and 1. How about like a half? Negative a half, that is. So again, all we need is the signs here. So if you plug in negative a half, -1/2 to the fourth power, well, that's a number that's less than 1. Okay, and it's going to be a positive number, less than 1. And so the whole top's going to be negative. Plug a negative half on the bottom, it's going to be negative, and that's positive. So this is -1/2. If we plug in positive 1/2, which is in between here, let me mark that down first. That's positive. Plug in positive 1/2, and we're going to get, again, a negative number on top, and we'll get a positive number on bottom, because positive 1/2 to the third is positive, and that's going to be a negative number. Plug in a number like 2. 2 is over here. Okay, so plug in 2. 2 to the fourth is going to be whatever, 16. Minus 1 is positive. So that's good. That's positive. Plug in 2 on the bottom, it's positive. So when we plug in 2, we get positive over positive. Positive over positive, which is positive. Okay, there you have it. Okay, so we tested some values, and we found our increasing and decreasing. And so we can say our increasing happens from -1 to 0 and from 1 to infinity. Okay, let's go put this is going down, this is going up, this is going down, this is going up. You don't have to draw these arrows, but I find them kind of helpful. Gives you a visual of what's going on with the graph. Okay, so we have decreasing, and that's happening from -infinity to -1. And from 0 to 1. Okay, so we found our increasing and decreasing. Last couple little things here. Okay, so the question here is, can the number, these number lines that we just made, can they tell us something about the more than just increasing and decreasing? Okay, looking at these examples, can we determine what type of extrema we have? Well, if we look through these here, notice this, we're going up and then we're going down. So what kind of point is it this in the middle? Well, that's going to be a maximum. And then here it's going down and then up. All right, that means this is going to be a minimum. Okay. Now here we're going down and then up. So that means this is going to be a minimum. -2 is a minimum. We're going up and then down, so this is going to be a maximum. We're going down and then up, that means this is going to be a minimum. Okay, and last but not least, we see the same idea, down and up. This is going to be a minimum at -1. This is going to be a maximum at 0 because it's going up and then down. Down and then up, this is going to be a minimum. So we starting to get a good idea of what the graph looks like. Okay, so if the sign changes, not the scene, if the sign changes on f prime, okay, then we have a min or max, an extrema. Okay? All right. So if we go from positive to negative, this equals a maximum. If we're going from negative to positive, this equals a minimum. And this is what we call the first derivative test. All right? So we'll wrap it up with this. The first derivative test tells us that if the derivative changes from negative to positive, then we have a minimum. If the derivative changes from positive to negative, then we have a maximum, relative maximum, that is. Okay. So these are relative. They're just not necessarily the lowest point for the whole function, but they're lower than its neighbors. And if f prime is positive on both sides or negative on both sides, then f prime of c is neither a min or a max. Okay? So if it doesn't change, like this situation here, it's neither a min or max. It's what we call an inflection point. So the first derivative test just tells us how it's changing and if we have a minimum or maximum. All right, great. Well, hope that helps. So go find those derivatives and find some increasing and decreasing, and it tells us mins and max.